theory is a study of some particular fields, We are calling it an electric field, a magnetic field. So here the term field is very important. So what is this field? We can define field like this. A field is distribution. A field is distribution in space of any quantity. A field is nothing but distribution in space of any quantity. That is either scalar, vector, or vector, and it is independent of time. It is either time dependent or time independent. That is, it may be time dependent or time independent. Depends. So we can define a field is nothing but a distribution in space of any quantity, either scalar or vector. It is a time dependent or time independent. One more thing, the field may be defined over the whole space or a portion of space. So it may be distributed only in a particular area, or it distributed along the entire space. Suppose scalar field, that is, if the quantity is a scalar, then the field is a scalar quantity. Suppose temperature distribution. Temperature distribution in a room. Temperature distribution in a room. Suppose if we consider a single room, so the temperature is uniform along the entire room. Or temperature is distributed. The quantity is distributed. So temperature is a scalar quantity. So the distribution of the temperature in a room. So here I am considering a particular region. So in a room. So the distribution of the temperature in a particular room is nothing but a scalar field. So room means it has three dimensions. Suppose I can define like this: f of xyz, which is the temperature distribution, x square plus y square plus 5z square. Suppose this is the temperature distribution. Suppose if I want to know what is the temperature value at a particular point 1, 2, 3, just to substitute the values. So we will get the magnitude of the temperature. So this is one of the example of scalar field. Because temperature is a scalar quantity, so distribution of the temperature in a room is a scalar field. Similarly, vector field. The quantity is a vector, then we can define vector field. Suppose example of vector field is wind velocity. Wind velocity distribution. Wind velocity distribution in a hurricane. Wind velocity distribution in a hurricane. So velocity is a vector field. So velocity distribution in a hurricane. So suppose I can represent graphically like this, the distribution of the velocity. In a hurricane we have wind with a particular velocity. It may be entire region or in a particular region also. So like this. This is the wind velocity distribution in a hurricane. So we can treat it as a example of vector distribution. Suppose how we can define a vector field is f of x, y, z is equal to, since it has a magnitude as well as direction, so this is some ax into ax cap plus ay into ay cap plus az into az cap. So this is the scalar quantity in x direction. So this is a unit vector along x direction. Similarly, scalar in y, unit vector in y, scalar in z, unit vector in z. So this is an example of a vector field, wind velocity distribution in a hurricane. So we can treat it as a vector field distribution. So here the important one is field. So the meaning of a field is nothing but the distribution of the quantity in space in a particular region or in along the entire space. Depends upon is a scalar quantity or vector quantity. We can determine, we can know either it is a scalar field or a vector field. So that is the meaning of a field. So a field is nothing but distribution in space of any quantity. It is either time dependent or time independent. Next we will define unit vector. What is unit vector? So in the name itself, unit vector. Unit vector means magnitude is unity. Suppose a vector a bar is like this. The magnitude of the vector a bar I am writing as a. Then unit vector a bar along a bar is defined as a bar is given by the vector by the magnitude of that vector. So that is nothing but a bar by a implies a bar is equal to a into a bar. So this is a vector, this is a scalar, this is a unit vector. So a vector is defined as magnitude, is magnitude multiplied with its unit vector. That is, suppose like this. This is a bar. This is a bar. So I can define this is the entire thing is magnitude of a bar. So I can define a unit vector a bar along a bar having magnitude 1. Having magnitude 1. So a unit vector is defined as that vector along a particular a unit vector along a particular vector is defined as that vector divided by magnitude of that vector. So suppose a unit vector along a bar is defined as a bar by magnitude of a bar. So we can represent any vector as scalar multiplied with its unit vector. Here I am introducing rectangular coordinate system. Rectangular coordinate system. This is also known as Cartesian coordinate system. Cartesian coordinate system. Rectangular coordinate system or Cartesian coordinate system. Actually, why we need coordinate system is, suppose in order to describe a vector accurately with some specific length and direction and angle or projections, we need some representation. Suppose a vector with 5 meter length is given. Suppose if I want to represent this in free space, then how I can represent? We need some specific, we need some configuration to represent a vector. So coordinate system is used for that purpose. Coordinate system is used to represent or in order to describe a vector accurately. So we can say that coordinate system is used to represent or to represent or to describe a vector accurately in free space. That is the advantage of using a coordinate system. There are plenty of coordinate systems, so we will discuss one by one in later our discussion. Suppose this is a coordinate system with x, y, z. The rectangular coordinate system is with represented like this: x, y, z. The first point is the three coordinate axes are perpendicular to each other. That is x, y, z are 90 degrees to each other. One more thing important is, generally, or it is customary to choose right-handed coordinate system. Right-handed coordinate system. That is like this. So this is x, this is y, this is z. I am moving towards the right hand. X to y, y to z, z to x. Left-handed coordinate system means like this. This is x, x to y, y to z. So the rotation is like this, which is a left-handed rotation, left-handed coordinate system. So for this rotation towards right-handed coordinate system. So generally we will use the right-handed coordinate system, that is x, y and z. X, y, z. Suppose the unit vector along x is defined as ax bar. The unit vector along y is given as ay bar. The unit vector along z is defined as az bar. Suppose a vector a bar, if I want to represent a vector a bar in a Cartesian coordinate system, a vector a bar in a Cartesian coordinate system is represented as a bar is equal to ax bar plus ay bar plus az bar. That is, the scalar component along x direction multiplied with the unit vector along x direction plus scalar component along y direction multiplied with the unit vector along y direction plus scalar component along z direction multiplied with the unit vector along z direction. So if you add all these three, we can represent a vector a bar like this. This is x, y, z. So this is ax, ay, az. So a vector can be represented like this. Any vector a bar is the addition of these three values. So then magnitude of a bar is given by square root of ax square plus ay square plus az square. Therefore, unit vector along a bar is defined as ax bar plus ay bar plus az bar divided by square root of ax square plus ay square plus az square. Suppose if I want to represent a point P, 3, 4, 5, the representation is like this: x, y, z, x, y, z. So point P, x direction 3. So x direction positive 3. So this is 3. Y direction 4. So this is 4. This is 3. So combination of these two. This one. Z5. So this is Z5. So you draw a perpendicular line, you will get at this particular point. So this is 3, 4, 5. So a vector, if you represent a bar like this, the vector is given by 3ax plus 4ay plus 5az. 3ax plus 4ay plus 5az. So like that we can represent a vector. So all these basics are needed for further discussions. So we will work out a simple problem based on this concept. The problem is, a vector is given as a bar is equal to minus 5ax minus 3x plus 2 ay bar plus az bar. So like this it is given, a vector. First one is, what is the scalar component of the vector in x comma y comma z directions? X comma y comma z directions. The solution to this is very simple. So a vector is given as minus 5ax minus 3x plus 2 ay plus az bar. So the scalar components, so the scalar component along x is minus 5. So ax is equal to minus 5. Ay, similarly the scalar component along y is minus 3x plus 2. Similarly the scalar component along z, az is 1. So directly we can represent. The second one is, what is the length of the vector? What is the length of the vector? So it is very simple. The length of the vector is nothing but magnitude a bar. So that is given by 5 square plus 3x plus 2 whole square plus 1 square. So this is nothing but square root of 26 plus 9x square plus 4 plus 12x. So that is nothing but square root of 9x square plus 12x plus 30. So depending upon the x value, we will get the magnitude a bar. So this is the length of the vector, which is dependent upon x. Third problem is, or third one, the unit vector in the direction of a bar is what? It's very simple. So the unit vector along the direction of a bar is nothing but small a bar is equal to the vector by magnitude of that vector. So this is nothing but minus 5ax minus 3x plus 2 ay plus az divided by square root of 9x square plus 12x plus 30. So depending upon x value, we can calculate the unit vector. So this is the unit vector along a bar. So it is a very simple problem. Next we define distance vector. Distance vector. So we can define distance vector as, distance vector is the displacement from one point to another. Distance vector is the displacement from one point to another. Suppose P is given as 3, 4, 5. Q is given as some -1, 2, 3. Then the distance vector between these two from P to Q is defined as RPQ. RPQ is defined as -1, 2, 3. That is Q, RQ. Only RQ minus 3, 4, 5. That is RP. So that is equal to, we will get -1 minus 3, -4 AX, 2 minus 4, -2 AY, 3 minus 5, -2 AZ. So this is the distance vector from P to Q. Suppose if you want Q to P opposite to this. So this is the distance vector. Next one is position vector. Position vector or radius vector. Suppose a point P is given 1, 2, 3. 1, 2, 3. So its position vector is, this is the coordinate system, X, Y, Z. Suppose this is the point P. So its position vector is from 0. You have to consider from 0 to the point RP. RP is given by 1, 2, 3 minus 0, 0, 0. So that is nothing but AX cap plus 2 AY cap plus 3 AZ cap. That is the position vector or radius vector. Suppose from this we can say that the position vector or radius vector of any point is nothing but a distance vector between the point to origin. The distance vector between the point to origin. So directly we can calculate the position vector. So we have to consider always the second reference point as 0 when you are calculating position vectors. Next problem is, we will work out a problem. Suppose if A bar is equal to 10AX minus 4AY plus 6AZ and B bar is equal to 2AX plus AY. 2AX plus AY. Find, first one is magnitude of 3A bar minus B bar. Magnitude of 3A minus B bar. So the solution to this problem is, first of all represent AR in terms of points directly. So A bar is nothing but 10, minus 4, 6. Similarly B bar is equal to 2, 1, 0. So calculate 3A bar minus B bar. So that is nothing but 3A bar minus B bar is nothing but 3 into 10, minus 4, 6 minus 2, 1, 0. That is 30, minus 12, 18 minus 2, 1, 0. So that is nothing but 28, minus 13, 18. So magnitude. So therefore magnitude 3A bar minus B bar is equal to square root of 28 square plus minus 13 whole square plus 18 square. So if you calculate, you will get approximately 35.74. Very simple. So directly calculate in terms of points to reduce the time. The second problem is, what is the unit vector? What is the unit vector along a bar plus 2b bar. What is the unit vector along a bar plus 2b bar? So the solution is, so the unit vector along a bar plus 2b bar is nothing but that vector a bar plus 2b bar by magnitude of that vector a bar plus 2b bar. So we know that what is first calculate what is a bar plus 2b bar. So a bar is 10 comma minus 4 comma 6 plus 2b bar. So this is nothing but 10 comma minus 4 comma 6 plus 2b bar. So directly we can write 4 comma 2 comma 0. 4 comma 2 comma 0 divided by magnitude of a bar plus 2b bar. So this is equal to 14 comma minus 2 comma 6 by square root of 14 square plus minus 2 whole square plus 6 square minus 6 square. So suppose if you want AX component is nothing but 14 by square root of the entire value. Similarly AY component is minus 2 by square root of that entire value. So like that you can easily calculate scalar components. So this is a total unit vector along a bar plus 2b bar. So AX into some unit vector along AX direction, that is scalar component multiplied with the unit vector. So you can calculate the unit vector very simply.